Hello friends, welcome to the channel. So today we are going to solve a typical type of questions which do come frequently in CAT. And the important thing about these kind of questions is more than 90% of the students do not attempt these kind of questions because of the complexity involved. But if you know the trick, if you know how to solve them, if you know the approach, these kind of questions are fairly easy to solve and you can get 100% accuracy. So today we are going to learn this particular type of question. It comes in the geometry section and it is based on the perimeter of the triangles. So before starting how to solve these kind of questions, one thing I would like to tell you, there are formulas also. Many teachers will teach you different formulas to solve these kind of questions. But I do not prefer formulas because generally in CAT level of exam, direct question is not asked where you just use the formula and you get the answer. They will always use some tricks or something like that, so you must be prepared for that. Another thing is, if you are for these kind of questions there are four formulas, you will have to remember four different formulas. So why to use that capacity of your brain, why to overload your brain with those formulas? Just learn the approach, how to solve these kind of questions. Every question of this kind you will 100% get accurately correct. So let's start. And before starting to solve, I will tell you some basics also. The basic concept is there are three type of triangles basically. Okay, one is equilateral, where all the sides are equal and the angle is 60 degree. Okay, one is isosceles, where two sides are equal, these two angles are same, and the sides are A and B. These sides are A, B and C, and it is equal to A, it is equal to A, it is equal to. Third type is scalene kind of triangle, where A is different, B is different and C is different, and all the angles are different. Another thing you have to remember is, in a triangle sum of two sides is always greater than the third side. Okay, so let us say a perimeter of a triangle is given, and if something is asked to you, let us say it is asked that how many triangles are possible with these kind of parameter. So if the with integral sides, if it is possible to form only 6 or 7 triangles, then you can use hit and trial method. For example, let us say parameter is 10. So you can solve like 2, 2 and 6, and you can try 3, 3 and 4. You can try various combinations and you can arrive up to around 6, 7 triangles are there. Out of that you can find out 2, 3 are equilateral, 2, 3 are isosceles, 2, 3 are scalene triangles. But if the number of triangles are, let us say, 34 possible, then you cannot do that hit and trial method because it is going to take a lot more time. So that is not a feasible method. So today we are going to learn a very important approach. In starting, I can guarantee you this approach will feel a bit hard to you, a bit complex to you. But once you solve one or two questions, I will guarantee you this approach which I am going to teach you, you will not forget the rest of your life, and 100% you can get this question right. Okay, so let's start how to solve these kind of questions. How many triangles with integral sides are possible if the perimeter of the triangle is 64? Also remember, with certain conditions, equilateral triangles will be represented by E, isosceles will be represented by I, scalene will be represented by S. Since equilateral triangle have sides A, only one combination will be possible. So whatever the number of equilateral triangles you arrive, okay, only you will consider it as a one case. Isosceles triangle, let us say 2, 2 and 10. You can write it as 2, 10 and 2. You can write it as 10, 2 and 2. So there will be three cases. In case of scalene triangle, let us say 2, 3 and 4. You can write these combination in 6. You can find 6 cases. So whatever the equilateral number you find out, you will divide by 1. So E is equal to E. We will learn now how to do that, but just remember this basic concept. Whatever isosceles triangle we find out, we have to divide by 3. Whatever scalene triangles we are able to find out, that will get you 6. Okay, so let's start. Okay, so let us say the triangle is having side A, B and C. Okay, how many triangles with integral sides are possible? Total number of triangles we have to find out. So A plus B plus C is equal to 64. Okay, and A, B and C, these have to be greater than 1 because integral sides, and these have to be less than semi-perimeter. Always remember that any side has to be less than semi-perimeter. So semi-perimeter is 64 by 2, 236, 224 divided by 32. So you can write it as A, B and C less than equal to 31. This is the one case. Okay. Then what you have to do is, since A plus B plus C is 64, if ABC is less than 31, if you are going to solve with these equations ABC, then you are going to get a lot many cases which will lie between 31 and 64. So solutions will be more. Your accuracy will not be right. So every time in these kind of questions, we have to move towards X, Y and Z. So what we will consider is, let A is equal to 31 minus X. Okay. B is equal to 31 minus Y. C is equal to 31 minus Z. So replace here. So A plus B plus C can be written as 31 minus X plus 31 minus Y plus 31 minus Z is equal to 64, or you can write it as 3 into 31 minus 64 is equal to X plus Y plus Z. Once you are used to solve these kind of questions, you do not have to write all these steps. You can directly come to X, Y, Z. Okay. So 313, 339, 93 minus 64. Okay. So 6, 7, 8, 9. It is 9. 13 minus 4 is 9. To 29. So X plus Y plus Z is equal to 29. Okay. And use here also. So 31 minus X is equal to 1. So X is equal to 30. So X, Y, Z is less than equal to 0 to 30. Now you can solve this, because X plus Y plus Z is equal to 29. If you are going to find out the number of integral solutions, X, Y, Z range is less than 30. Every possible solution you will get. That's why we have moved towards X, Y and Z. Okay. Now there is a formula to find out the number of total cases. It is given as N plus R minus 1 C R minus 1. Okay. Here N is 29. See, you don't have to go to that much basics how we are able to do this. Just solve one kind of questions. I will solve 4 to 5 questions today in front of you. Every question will be solved like this. Just remember this approach. Every time you will get your answer 100% right. N is 29. R is equal to 3 because X, Y, Z, 3 variables are there. So 29 plus 3 minus 1 C, 3 minus 1. So it is 29 plus 2, so 31 C 2. It can be written as 31 into 30 into 29 factorial divided by 2 factorial into 31 minus 2, 29 factorial. This cancel, 215. So this is 31 into 15. Let us solve this. 31. It is 465. Okay. So E plus 3I plus 6S is equal to 465. E is the total number of equilateral triangles. I is total number of isosceles triangles. S is total number of scalene triangles. Why we have used 3 I and 6s, because I told you total 3 combinations are possible for I isosceles and 6 combinations are possible for scalene. So we are initially using multiplication, then we have to divide. So E plus I plus S we have to find out. Okay. Also another trick here is, if this initial number, this parameter, if this is divisible by 3, if this is divisible by 3, then equilateral triangles is 1. If this is not a multiple of 3, then this will be 0. So E is equal to 1 or 0 depending on if this is a multiple of 3n. Okay. So 64 is not a multiple of 3. How do I know it? Any number, let us say 1, 2, 3. Is it divisible by 3? Just do the sum of these numbers. 3 plus 2, 5 plus 1, 6. 6 is divisible by 3. So definitely 1, 2, 3 will all is a multiple of 3. 6, 4. 64. 6 plus 4 is 10. 10 is not divisible by 3. So this is not divisible by 3. You can use this trick anywhere. For example, you can use 18. 1 plus 8 is 9. 9 is divisible by 3. So 18 is a multiple of 3. Okay. So here E will be 0. Okay. E gets cancelled. Now what we will do is, here let us say we have to find isosceles triangle. So in isosceles, two sides will be equal. So let us say x is equal to z. So 2x plus y is equal to, we are going to use in this equation, 2x plus y is equal to 29. Now x will range from 0 to x is equal to 29 by 2 is around 14 something. So x will range from 0 to x is equal to 14. So this will give us 15 cases. Okay. Since E is equal to 0, so we will not consider E. If E would have been 1, then this 15 cases would have contained that E also. So we have to minus 1 E, one equilateral triangle from these isosceles triangles. Okay. Always remember this approach. Do not go into that much basics. Once you are able to solve 2-3 questions, every time it will be right. If you go into the theorems and all, then it is going to be much difficult for you. You are not here to do PhD. You are here to just clear a CAT exam and get a MBA college. Okay. So 15 cases we have got. So put here 3 into 15 plus 6s is equal to 465. So 15, 3, 45. So 465 minus 45, 642, 4, 420 by 6, 6, 7, 42. So 70. So S is equal to 70. So total number of triangles are E plus I plus S. E is equal to 0, I is equal to 15, S is equal to 70. This is 85. 85 triangles integral solutions are possible. Okay. So here the answer will be 85. How many triangles with integral sides are possible? If the perimeter of the triangle is 64, 85 triangles are possible. You could not have done this with hit and trial method. 85 cases you have to solve. That is not possible at all. Okay, given limited period of time. So this is how you solve this question. Let us see another question. Okay, you will get confidence. How many isosceles triangles with integral sides are possible? Here we do not have to find E plus I plus S. We have to find only E, only isosceles. Same approach is here. A plus B plus C is equal to 37. A, B, C lies between 1 and parameter is, semi-parameter is 37 by 2, 2 and 2, 2, 8, 16 and 5, 10, 18.5. So less than that 18. Okay. Now 37 and 18 difference is huge. There are going to be a lot more solutions. So we will use X, Y and Z. So X, Y and Z, this will be 0 and A is equal to 18 minus X. Okay, so 18 minus x is equal to 1, so x is equal to 17. So 17. Okay, and we have to put here x, y, z. So directly we can do x plus y plus z is equal to 3 into 17 minus 37. 51 minus 37. 21, 3, 4, 5. So 7, 4, 14. So x plus y plus z is equal to 14. Okay, let me. Okay, perfect. Here solution can be done by n plus r minus 1 c r minus 1. N is 14, r is always 3, so r minus 1 is going to be 2. 14 plus 2 c2 is equal to 16, c2 is equal to 16 into 15 by 2. You have to be a bit fast. Once you solve one or two questions, it will be easy for you. So 15 into 8, 8 by 40, 120. So there are total 120 solutions. So E plus 3I plus 6S is equal to 120. Okay. Now, is this 37 divisible by 3? No, it is not a multiple of 3. So E is going to be 0. So 2x plus y is equal to, consider isosceles triangle, 2x plus y is equal to 14. Okay. So x is going to range from 0 to 7. So there are total 8 cases. So I is equal to 8. And this I does not contain equilateral triangle because E is already 0. So here we do not have to find E plus I plus S. I we have find out. So isosceles, the answer is going to be 8. This is the right answer. Simple. Let's see the another question. Here we have to find scalene triangles. How many scalene triangles with integral sides are possible? Same approach. A plus B plus C is equal to 54. A, B and C less than equal to 1 less than equal to 1 less than semi-parameter. So 2 to 4, 2, 7, 14. So 26. Difference is huge. So A is equal to 26 minus x. So x plus y plus z is equal to 3 into 26 minus 54. Okay, let me check, cross verify again in last question if I have done right here. Okay, so 6, 3, 18, 3 to 6, 7 minus 54, 4, 2, 24. So x plus y plus z is equal to 24, and AB x, y, z, it values lie between 0 and so 26 minus x is equal to 1, so x is equal to 25, less than 25. Okay, now n is 24, so 24 plus 2, 26, c2 is equal to 26 into 25 divided by 2, 13, so 13 into 25, 3, 15, 36, 7, 25, 5, 3 to 5. So E plus 3I plus 6S is equal to 3 to 5. Now here 54 is divisible by 3 or multiple of 3. How do we know that? 5 plus 4 is equal to 9. 9 is a multiple of 3. So 54 is divisible by 3 or multiple of 3. So E is equal to 1 here. Okay, E is equal to 1. Now again we have to find for I. So 2x plus y is equal to 24. So x range from 0 to 12. So there are 13 cases. Minus 1. 13 minus 1. Why? Because E is equal to 1. It will also contain one equilateral triangle case. So there are 12. I is equal to 12. So put here. So 1 plus 12 into 3, 36 plus 6s is equal to 3 to 5. So 6s is equal to 3 to 5 minus 37. So 8 and 1. So 28. So 28. So S is equal to 288 divided by 6. So 6, 4, 24. and 6 8 48. Answer is 48. So scale in triangles is number is 48. This is the right answer. Let me see. Option is not given, but 48 is the right answer. So we have learned how to find out total number of triangles given certain parameter. We have learned how to find out total number of isosceles triangles. We have learned how to find out total number of scale-in triangles. Equilateral triangles is easy. It is equal to 1 if that parameter is a multiple of 3. It is equal to 0 if it is not a multiple of 3. Let's see the final question. Okay, how many isosceles triangles with integral sides are possible? This question I would request you to please pause the video, give it an attempt, and then see the solution. It is going to be good for you. How many isosceles triangle with isosceles I we have to find out. Parameter is 24. A plus B plus C is equal to 24. So A, B, C lies between 1 and 11. So X plus Y plus Z is equal to X plus Y plus Z is equal to, so A is equal to 11 minus X. Okay, so 11 into 3 33 minus 24 is equal to, so 24 plus 9, so 9, and X Y Z is less than equal to 0 and less than equal to, so 11 minus X is equal to 1, so X is equal to 10. So 10, this equation and this equation, and n plus r minus 1 c2 r minus 1 can be given as n is equal to 9 here. So 9 plus 2 11, 11 c2 is equal to 11 into 10 divided by 2, so 5 is equal to 55. So e plus 3i plus 6s is equal to 55, and 4 plus 2 is 6, 6 is a multiple of 3, so e is equal to 1. So e is equal to 1. Okay, use here 2x plus y is equal to 9, so x is equal to 0 to 4. There are 5 cases, but this case also involves one equilateral case, so I is equal to 4. This is the right answer. 4 is the right answer. We have to find out only isosceles. If we would have wanted to find out the total number of triangles, what we will have done here, put e is equal to 1 plus 3 into 4 12 plus 6s is equal to 55. 6s is equal to 55 minus 1 is 54. 54 minus 12 is 42. So s is equal to 7. So e is plus I plus s is equal to 1 plus I is 4 plus 7. So 4 5 7 5 12. So total number of triangles possible are 12 if we would have wanted to find out total number of triangles. So this is how we have to solve these kind of questions. This is a very important concept. These do come frequently in CAT, and more than 90% of the students leave these kind of questions. The reason is they do not remember the formulas. We have not even learned the formulas. We do not require the formulas. Just remember this approach. So it is going to be super easy for you. Another thing why students leave this topic is that if the question comes a bit tricky, formulas are not used, so their accuracy is not right. But for us, accuracy will be 100% always. Not just in CAT, in EXAT also, in NMAT also, even in GMAT also you can get these kind of questions. So please do practice it. Just practice these 4 questions what I have given you in this video. Those are sufficient enough. Nothing out of this syllabus will come from this particular topic. So wish you all the best. Let's meet in the next video. In next video I will try to cover a bit of trigonometry. If any particular topic you want to get covered, please let me know. We will provide a video solution and we will come with a very good video for you. So till then, bye bye.